All right, folks, this is lesson 7.3.3, identifying quadrilaterals on a coordinate grid, and there's nothing new in this lesson. We've done this work before. This is just additional practice. There are 3 problems we're going to do. It's one problem, 3 parts, 7-139, the shape factory. So in part A, part B, and part C, we're going to identify the most specific name we can for that quadrilateral. Might be beneficial to have your quadrilateral org chart out right now so you can refer back to that for different properties. Remember what we need to do. We're looking at lengths and slopes for each segment in the quadrilateral. For lengths, we're looking for congruence. That's if the lengths are equal. And for slopes, we're looking for parallel. And that's equal slopes. Or perpendicular. And that's when we have opposite reciprocals. Okay, so let's get after it with this first one. I'm going to start by looking at segment HE. Easy enough to count the squares on the grid here, but I'm going to go ahead and run through the formula just to give you some practice. Might be helpful to write out the coordinates of each of these points first. H is at 0, 3. G is at 2, 0. F, that's 4, 3. And E, that's 2, 6. So the slope of HE is delta y over delta x. That's 6 minus 3 over 2 minus 0, 3/2. The length of HE, delta x squared plus delta y squared. Remember, that's our distance formula. It's just an adaptation of the Pythagorean theorem. Delta x is 2, delta y is 3. 2 squared is 4, 3 squared is 9, 4 plus 9 is 13. And we can go ahead and write that as an approximate decimal. You know what, folks? I decided I'm not going to write that as approximate decimal, and here's why. Because when I'm looking for congruence, I just need equal length. And equal length means I just need to compare numbers. So I can compare the square root of 13 just like I can a decimal value that's approximately equal to that. So I'm not going to bother with that. All right, let's move on and let's look at the next segment. Let's go ahead and look at side EF. Got a slope of negative 3/2 and the length square root of 13. So far I notice that both those lengths are the same. We'll talk about the slopes in just a minute. Highlight something here. I got that delta x is negative 2. That's because I did the 2 minus 4 to get negative 2. Note when you square that, it becomes a positive number. If you ever get a negative number when you're working underneath the square root, you need, especially if we're talking about distance, you probably made a mistake. Slope and length. We got one more side to do here. It's GH. Slope of negative 3/2 and a length of, I bet you can see where this is going, root 13. Okay, so let's take a look here. I'm going to highlight some things. We have the lengths of all 4 sides are congruent. So let's make a note of that. Actually, I'll move it over here because I got some space. I have 4 congruent sides because I have all 4 sides of that quadrilateral have the same length. Now let's take a look at some slopes here. I've got this slope here of 3/2 and 3/2, and if I look at HE and I look at GF, those are opposite sides that have the same slope. That means they are parallel. Actually, there's another mark I should add to the figure. I should add the congruent marks because I've already showed that all. Let's take a look at one other pair of slopes here. So let's also take a look at these 2 slopes here. I got EF and GH with a slope of negative 3/2 for both of those. So that means those sides are parallel as well. I have to put a different mark on those sides to indicate that it's a different parallel relationship than the other side. the other set of sides. The one thing I do want to comment here is take a look at these two slopes right here. This one and this one. Those are not, they don't have that perpendicular relationship. Remember, perpendicular is opposite reciprocals. Those are opposites, but not reciprocals. Okay, so we have 4 congruent sides. We also have opposite sides parallel. So this idea right here, this makes it a parallelogram. But we can even be more specific than that. The fact that we have 4 congruent sides makes it a rhombus. By definition, that's what a rhombus is. So let's go ahead and finish this off with a nice conclusion. We can say that quadrilateral HEFG is a rhombus because it has 4 congruent sides. All right, let's look at the next example. Okay, folks, for this one we have quadrilateral ABCD. Coordinates for each of those points is already labeled for us on the graph. Let's go ahead and do this one. Just take a quick little shortcut on this one. Let's do all the slopes really quickly. And let's do the slopes by just counting on the graph. So to get from B to A, I have to rise 2 and run -1. So that is a slope of -2. Rise 2, run -1. 2 divided by -1 is -2. Let's go ahead and look now at BC. So to get from B to C, I have to rise 3 and run 6. 1, 2, 3, 4, 5, 6. So I rise 3, run 6. That reduces to 1/2. Let's now take a look at the next set of sides, which is CD. I rise 1 and I run -3. Rise 1, run -3, delta y over delta x, -1/3. Last but not least, let's look at DA. So let's see, to get from D to A, I have to drop down 2. So that's a delta y of -2. And then my delta x is -4. -2 divided by -4 is +1/2. Okay, so let's just take a look and see if we have any relationships here that are worth noting. AB's got a slope of -2. I don't see that slope anywhere else. I also don't, oh, well, wait a minute. Wait just a minute. Let's take a look at those 3 slopes. So if we take 1/2 and we look at the opposite reciprocal, that would be -2/1, and that equals -2. So that means that we have that perpendicular slope relationship. So AB is perpendicular to BC, and AB is perpendicular to DA. Let's go ahead and add those marks in the figure. Okay, so because we have those right angles there, because we have perpendicular relationship, I added the right angle marks. Here's the other thing. Do you notice this? We have a C shape right here. That's same side interior angles, and those same side interior angles add up to 180. So that makes them parallel. That makes those side lengths, those sides parallel. So I'm going to add that to the figure. So automatically right now, if you're looking at that, you're like, I know it's a trapezoid. I absolutely know it's a trapezoid. From here, we are going to just calculate side lengths real quick just to see if there's anything else crazy going on. Okay, folks, for the side lengths here, I'm going to rip through this by drawing in all of the right triangles and the leg lengths that correspond to each side in the quadrilateral so that I can use the Pythagorean theorem really quickly. So this one right here, I got a 1 and a 2. Here, I have a 6 and a 3. Here we have a 1 and a 3. And then the last guy we have here is a 2 and a 1, 2, 3, and a 4. So I'm going to use that now to help me calculate the length of all the sides in the quadrilateral. We'll start with AB. 2 squared, 4, 1 squared, 1, 4 and 1 is 5. Okay, folks, there you have it. And as suspected, none of those numbers are equal, so we don't have any congruent sides. We now need to make our final conclusion. And we already alluded to this. ABCD is a trapezoid. Why is it a trapezoid? Because it has one pair of opposite sides that are congruent. In addition to it being a trapezoid, we can be a little more specific than that. We can actually say it's a right trapezoid, because we have those two right angles. Okay, let's now jump down to the third and final problem, part C. Now this one, trapezoid WXYZ, when you first look at it, you're so tempted to just say, you know what, I know this is a kite. I'm going to go ahead and mark it like this, and I'm going to be done and say it's a kite. But not so fast, my friends. That would be unfortunate if you did that, because, well, I think it's going to be wrong. What we need to do here is we need to calculate lengths and slopes for all the sides. We're helped out a little bit here because we have one side that is horizontal. So I can just jump right in and say that side length XY is 3. And then again, we're talking about segment XY. The length is 3. And then the slope of XY is 0 because it's horizontal. I also have a vertical segment here that's pretty easy to check. That's YZ. Well, the length YZ, I can count squares here. That's, let's see, 1, 2, 3, 4, 5, 6. That's 6 units long. Can't do that on a diagonal, but you can do it on a vertical or a horizontal. And let's take a look at the slope of YZ. That's undefined. Vertical lines have a slope which is undefined, and I'll just show you why real quick. Let's look at delta y over delta x. Let's see, delta y is 7 minus 1. Delta x is 5 minus 5. That would be 6 divided by 0, and division by 0 is an undefined operation in math. Okay, so we've looked at 2 of the 4 sides. Let's go ahead and look at the other 2 here real quick. We'll look at ZW first. Distance formula gives me 5 squared plus negative 4 squared. That's 25 plus 16. And that's the square root of 41. Now let's look at the slope. Delta y over delta x is 1 minus 5 over 5 minus 0. That's negative 4/5. And we have one other side to look at here. We need to look at side length WX. I know the order doesn't matter, but I like to tell you that this is delta x squared plus delta y squared, so I'll do the delta x first. And now the slope. Okay, so we got a slope of 1 for that last one. I want to show you one thing real quick. I don't know if you noticed this, but this is really a isosceles right triangle. It's a 45, 45, 90 right triangle. So this length right here should be equal to the side length times root 2. It should be 2 root 2. And I'll actually show you really quick that it is. We calculated root 8, but the square root of 8 is really the square root of 4 times 2. And the square root of 4 is 2. And we're still left with that root 2. So that's just a little bonus footage there for you to show you that, yeah, the 45, 45, 90 rule that we talked about in previous lessons actually works. So let's go ahead and make a conclusion here. So we got to go back and look at our slopes and our lengths. Let's first highlight the slopes. We've got horizontal, vertical, negative slope, positive 1. So none of those are equal, and the only thing we have is one relationship here of perpendicular. That's all we can say there, because horizontal lines and vertical lines are perpendicular. but nothing else. So there's no parallel, but we have one pair perpendicular, and that's xy and yz. Okay, now let's go back and take a look at our side lengths. I'll go ahead and highlight all the side lengths here. 3, 6, square root of 41, and square root of 8. None of those are equal, so we have no congruent sides. And that's all we can say. So all we can say here is WXYZ is a quadrilateral. It's not a parallelogram, it's not a rhombus, it's not a trapezoid, it's not a kite. That's it. Okay, folks, that's it for actually Chapter 7. We're done with Chapter 7. Stay tuned for some wrap-up activities in Chapter 7.